Hello everybody, this is Mr. Bowman. Today we're going to be looking at the first of our transformations, and these are translations. So a translation is when you take a graph and move it in a direction. So I'll either take the exact same shape and move it up, down, left, or right. Okay, so we're kind of limited in our options. So this is kind of like an Etch-a-Sketch, if you've ever played with that. One knob goes up and down, the other one goes left and right, and then by doing both of them together, you can get some diagonals and stuff like that. But the actual shapes are not going to change. Okay. So if I have a point, say I have a point here at I don't know, -1, 2, then I can take that point and shift it around. So maybe I want to move it right 4, so I would take this point and move it 4 points this way, and where would that land me? So looking at this, if I'm going right and left, which coordinate of my point has to do with right and left, and that's the x coordinate. So that means I'm going to take my x coordinate and I'm moving right, so I'm going to add 4. If I was going left, I would subtract. I'm going to add 4 to it, and that means this point would have to be at 3, 2, so definitely not to scale. Okay, so that would be right and left. But I do have my other option with translations. Maybe I have a point here at 2, 2, or something like that. 2, 2. And I want to go down 6. Okay. Then it's the same idea. I'm going to take this and shift down 6, so I've got to figure out where that would land. So in this case, I'm not going to use the x coordinate anymore. I'm going to use the y coordinate because I'm going up and down. So if I was going up, I would add, but I'm going down, so I'm going to subtract. So I'm going to subtract 2 from my y coordinate here. My x coordinate will stay the same, so that will still be 2. Then I'll have 2 minus 6, so this is going to land at 2, -4, somewhere down here. Okay. So if you have a graph, you can also count this off and say 1, 2, 3, 4, 5, 6, but either way, you're going to land on the same thing. All right. Now, sometimes you do end up doing both of them, and you'll have a set of directions. It'll say something like go down 1 and left 2. Okay. So in that case, if I'm starting over here at 3, 3, according to my marks, then I'm going to go down 1 and left 2, so that it would land me over here, so down 1 over 2, right? Which it looks like, if I look at the graph, 1, 2, which see if it makes up here. So I'm going down 1, so that's my y coordinate, went down by 1, 3 to 2, which is correct, and left 2, so I'm going to subtract 2 from my x coordinate, which also works. So counting or moving, it doesn't really matter if you count directly on the graph or if you add and subtract the numbers. You should land in the same place. Now, this level with points and stuff you probably saw at some point in Algebra 1, but where this is building up to is we're going to move entire polygons. So what I mean by a polygon, without getting into the super strict definition of it, we'll get to that later, but it's going to be a shape with vertices. Okay, so maybe we'll go with one of our classic ones and take a triangle. Okay, so if I have a triangle here, let's say, some things here. So my coordinates, and I'll call this A, B, and C. This shape, by the way, since it's before I'm moving it, is known as the pre-image. Okay. And the one after I move it's going to be known as the image. And that'll help me just keep track of things. So that's one of the ways that we do that. Okay. And then the other one is with a notation I'm going to use in the actual picture itself. Okay. All right, so now that I have this, let's take each of these points, and I'm going to do it without the coordinates this time. I'm going to do it by counting and see how that lands. So in order to do that, I need a transformation. So let's go up 1, so we don't fall off the graph, and right 4. Okay, so if I have a polygon as opposed to a single point, I want to move all of these points, but I can do it rather simply by just moving the vertices. So let's do a C first, because the order doesn't really matter. So I'm going to go up 1, and then over 4. 1, 2, 3, 4. And then after I move it, since that's the C1, I'm going to write C prime, which means it's the new C. Okay. So that's my new, then as I keep track, I'll know which point moved where. With translations, it's not as big of a deal, but with some of the other ones, it gets tricky. So it's just a good habit to get into. So up 1, 1, 2, 2, 3, 4. So that's B prime. Here, 1, 1, 2, 3, 4, A prime, and then I can connect those together, and it is my new graph, and it should be the same size, the same shape, everything, just slid over to the side there. Okay, so that's translations. Now, sometimes with these, it will change the notation just a little bit. So instead of getting in this, because we try and get away from language-dependent notation in math, and so up, right, down, left, all of those are English, so you'd have to translate those if you're going to a different language. So you'll often see this notation. Okay, you're going to take x, y here, and it'll say changes to, and it will give you something going on over here telling you how x, y changes. So if I take this one, right 4 is the one that's dependent on x, so it's going to be x, and so I'm going to go right, so that's plus 4. And then my y value, I'm going up, so that's also addition, plus 1. So this says take your any xy point and add 4 to x and add 1 to y. Okay, so if I looked at my point here with A, it's starting at -1, 2. Okay, so -1, 2 is my starting point. I'm going to add 4 to my x coordinate, so that'll take me to 3, and add 1 to my y coordinate, which would actually also be 3. So that means A should be at 3, which it is when I move it. So that's how this notation works, which is a slightly better notation, honestly, than this one, because it shows up the same way, whereas these could be flip-flopped and moved around. And you have to remember which one's positive, which one's negative. This tells you directly what to do, which is nice. So that's a good notation to get in the habit of using, and you'll probably run into it quite a bit.